All right, in this lesson, we're going to do a process called simplifying a radical. Now, you've actually already done this with perfect squares and perfect cubes. If I ask you to simplify a radical, for perfect squares or cubes, take the indicated root. Example, if I said, what's the square root of 81? If I said to simplify that, you would say, well, that's the rational number 9. If I said, would you simplify the square root of x to the 10th? You would say, sure, that's x to the 5th. Well, what if it's not a perfect square? For non-perfect squares, and we're really going to just stay with the perfect square, work with the squares. We're not going to really go with the cubes much. You factor out the largest perfect square factor. Take the root of the perfect factor and leave the other factor under the, let me scoot this down, radical. Let me give you one example before we get into these kinds of problems. If I ask you to, and it's key that you understand that the instruction would say simplify the square root of 20. Now I hope you recognize that 20 is not a perfect square. If it were, you would do something similar to what we did up there. It's not a perfect square. So what you try to do is you try to factor it. Is there a perfect square that goes into 20? If you need to, you look at your list. Is there a perfect square that goes into 20? And the answer is yes, 4. So I'm always going to put the perfect square in the front radical and the non-perfect square in the back radical. It does not do you any good to factor this as 2 times 10 because you must have a perfect square. If you do it and one of the factors is a perfect square, the square root of 4 is 2 and leave 5 under the radical. This is considered 2 times the square root of 5. If you're dealing with variables with powers and you're trying to simplify, if you have the square root of x to the 9th, you need to factor it. When you're simplifying radicals, you're factoring. You want the largest perfect square factor. Now, factors of variables with exponents, remember the product rule. So x times x to the 8th would give us x to the 9th. X squared times x to the 7th would give us x to the 9th. X to the 3rd times x to the 6th would give us x to the 9th. You want to have the largest even exponent because remember you're trying to get the largest perfect square, and a variable with an exponent is a perfect square if the exponent is even. So what I'm going to do is always take 1 off of an odd exponent. Put it over here. There's an implied 1 there that I don't write. That will leave an even exponent there. Now I can simplify this one. It's x to the 4th, and it leaves square root of x. All right, so we're finding the largest perfect square factor, and the other factor stays under the radical. That's called simplifying a radical. Let's take a look at some. Number 1, simplify the square root of 175. You have to find a perfect square that goes into 175. One way to do that is to be aware of the chart. What goes into 175? Well, because it ends in a 5, I'm thinking maybe 25. It might be a guess and check. Well, let's see. If you take 175 and you divide it by 25, and you can do that with your calculator quite easily, you get 7. In other words, 175 is 25 times 7. So it is the square root of 25 times the square root of 7. There are other ways to factor that, but remember, perfect square factors. Perfect square factors. Use your list. The square root of 25 is 5. When you take its square root, the radical is gone, times the square root of 7. 5 times the square root of 7. Number 2, what is the square root? It says use the product rule because you are breaking it into factors. The square root of 75, because it ends in a 5, I want to test 25. Does 25 go into 75? Yes, it does. It is 25 times 3, both under radicals. Square root of 25 times the square root of 3. The square root of 25 is 5 times the square root of 3. Next one. Okay, the first thing I wonder is it a perfect square? 36 is a perfect square. A to the 4th is a perfect square. Oh, b to the 7th is not. Remember, your exponent needs to be even. So I'm going to break it into 2 radicals. In the first radical, I will put the perfect square factors. 36. A to the 4th. Now b to the 7th. 7, because it's odd, is not a perfect square. It's not the exponent of a perfect square factor. So I take 1 away, putting it over here. That leaves me 6 factors there. Now I've got a perfect square factor. The square root of 36 is 6. The square root of a to the 4th is a to the 2nd. The square root of b to the 6th is b to the 3rd times the square root of b. This is simplifying radicals. First break it into a product, and the first radical must contain only perfect squares. All right, let's look at number 4. 4x to the 7th. 4 is a perfect square. X to the 7th is not. The way we deal with variables with exponents is we take 1 away, and that leaves 1 fewer, but it will be even. The square root of 4 is 2. The square root of x to the 6th is x to the 3rd times the square root of x. Let's look at number 5. Wants us to simplify the square root of y to the 17th, which is not a perfect square because the exponent is odd. I take 1 away from it, 1y out there. That leaves me with an exponent of 16. Now that's a perfect square. It is y to the 8th times the square root of y. Let's look at this last one. All right, negative sign on the outside of a square root is fine. It just becomes part of the answer. 448, is that a perfect square? Let's go look. Nope, 448 is not in my list. So I'm going to have to simplify it, and I want to show you my technique for simplifying large numbers, trying to find the largest perfect square factor. All right, this is just my technique. 448. It's not a perfect square. I don't know what the largest perfect square factor is, but since it's even, maybe 4 goes into it because that's a perfect square. And I'm going to box it, a square. 4 goes in there 112 times. That's not a perfect square. But I wonder if a perfect square goes into it. Because it's even again, I'm going to try dividing it by 4. And it goes in there evenly. It's 4 times 28. That's a perfect square. 28's not a perfect square. Does it have a perfect square factor? You've done something similar to this with prime factors. I'm not looking for primes. I'm looking for perfect squares. 4 still goes into 28, and it goes in there 7 times. Now here's something that you may or may not have known, is that if you have perfect square factors and multiply them together, you will get a perfect square. So if you multiply those, 4 times 4 is 16 times 4 is 64. 448 can be broken down into, and I'm doing, remember, perfect squares up front, leftovers back here. 448 is 64 times 7. I did not know that when I started the problem. I don't just wake up in the morning knowing that 64 times 7 is 448. But it does, that is the largest perfect square factor. All right, x to the 6th, that's a perfect square. It goes up here. Y to the 15th, because that's odd, it is not. A single y needs to go back here, and y to the 14th up here. What does that give me? Don't forget your negative because of the original negative out here. The square root of 64 is 8. The square root of x to the 6th is x to the 3rd. The square root of y to the 14th is y to the 7th times the square root of 7y. And that is my simplified answer. This technique will sometimes help you when you don't recognize as something a perfect. What is its largest perfect square factor? If it's even, try dividing by 5. If it ends in a 5, try dividing by 25. And then you certainly can just try other numbers. And also remember that if you get lots of perfect squares, if you multiply them together, you'll get a bigger perfect square. And you need the largest. Okay? Work on simplifying radicals.